I know it's upside down, but just bear with me. It says which statement is correct, right? And what did you write as your answer? An absolute maximum must be a maximum turning point. Is that what was that your answer?
I don't have it on me right now.
Okay.
Do you want to go get it?
No. That's all right. Basically, that one looks like the one that you've highlighted. Um, let's go through each one of these, right? So you've
Yeah.
got all stationary points are turning points. Is that right?
Yeah.
No. The answer is no.
Oh,
Can
yeah, sorry.
can you think of a stationary point that's not a turning point?
Um, um, just like normal like x values, like it can just pass through, like doesn't have to be a turning point.
Yes, but they're not going to be stationary points either. Normal x values. They're not going to be stationary points.
Yeah,
Yeah.
sure.
What are the different types of stationary points? Do you remember what they are?
Um, inflection.
Yes, horizontal point of inflection. What else?
Um,
Both
um,
starts with M.
minimum.
Yes, and starts another one that starts with M.
Maximum.
Yeah. All right. So what are the three types of turning points? There's only three.
Um, maximum, minimum, and inflection.
What type of inflection?
Horizontal.
Yep. Okay. So what about a normal point of inflection? Is that a stationary point
Um, a normal point.
of inflection? Is that a stationary point?
I think so.
Um, what is it? What is the definition of a stationary point?
A century point is basically when y dash is equal to 0.
Yes, when the first derivative is equal to 0. Yep.
Yeah.
So is that going to be the case for a normal point of inflection?
I don't think so.
That's right. So is a normal point of inflection going to be a stationary point?
No.
No. What type of stationary point is going to be a point of inflection? So what type of point of inflection is going to be a stationary point?
A horizontal point of
Yes.
inflection.
All right. So here's what we've got. Here are our different types of stationary points. That. Yep. That. Yep. And
Yep.
that. Got it? They're your three types. One, two, three. Got it? Can you have any other type of stationary point?
No.
Yeah, they're your three types of stationary points. Got it? Yep. So one, two, three. Yeah? Now,
Yeah.
how many of them are turning points?
Um, all of them?
No,
Oh,
just these two. Just those two. They're turning points. Okay?
yeah.
And that's not a turning point.
Mm-hmm.
Okay?
Yeah.
What's that?
Um,
If it's not a turning point, what would it be?
a stationary point?
Yeah, it's a type of stationary point. It's a point of inflection,
Yeah.
and it's also a stationary point as well. But it's not a turning point.
Okay.
Okay? Got it?
Mm-hmm.
Yep. Now, if you get stuck on any of that at all, all right, let me go through here. What I want you to do is kind of look here. Let me go through this with you.
Okay.
Watch this bit here. We're not going to watch the whole thing. I just want you to see the graph that I've got.
Hi, this is Sun from Sky Academy. I'm the
Okay.
principal and director, and basically what we've been doing.
Let me get out of the. Let me try and get myself out of the way.
And we've been looking at a number of different features, but now it's time to do a quick check and start.
All right, cool. Hold on. Beautiful. Now, here's what I want you to notice, right? Stationary points, they're your three types of stationary points, right? Stationary point, stationary point, stationary point. Got that?
Yeah.
These two are turning points. Maximum, minimum. They're your two turning points. These two are points of inflection. Got it?
Mhm.
A regular point of inflection is not a stationary point, but a horizontal point of inflection is a stationary point. It's not a turning point, but it is a point of inflection. Got it?
Yeah.
Okay. Now, the first derivative for a stationary point is always equal to 0. Yep.
Mhm.
But for a regular point of inflection, it's not. It's going to be either positive or negative. Yep.
Yeah.
For the second derivative, right? For the second derivative, which measures what? What's the second derivative measure?
Concavity.
Concavity, yeah. For a maximum, it's negative. For a minimum, it's positive, right? For points of inflection, right? The
Yeah.
the second derivative will equal to
0.
0, but that's not the only thing. What else needs to happen for it to be a point of inflection?
The concavity needs to change.
Yes, there needs to be a change in concavity. Yep. So in other words, the second derivative has to move from positive to negative or negative to positive, right? For
Yep.
both a horizontal point of inflection or a regular point of inflection. Got it?
Yeah.
Get really familiar with this, right? And know the difference between a turning point and a stationary point, etc. Does that make sense? And the difference between just a horizontal point of inflection and a regular point of inflection.
Yeah.
Got it? Cool.
Yeah.
So, let's have a look at this. All stationary points are turning points. Is that right?
No.
That's right. Because a horizontal point of inflection is not a turning point. Okay? But it is a stationary point. All turning points are stationary points.
All stationary points.
No, all turning points are stationary points. Is that true?
All turning points are stationary points.
Yeah.
Yes.
Yes,
True.
that's right. That's the answer. Okay?
Okay.
So maximum minimum is also a stationary point, right? But there's also another type of stationary point, which isn't a turning point, which is a horizontal point of inflection. Got it?
Yeah.
And then there's part C. An absolute maximum must be a maximum turning point. Is that right?
I thought it was right because if you have like an absolute maximum, then it's like its point is like concave down.
Yep. I see what you're saying.
Wouldn't that be a maximum turning point?
Well, the key word here, right? The key word here is the word turning point. Okay? So let's say, for example, you have a graph, right? And it kind of looks like this. Okay? and it's between this domain and this domain. Where would the absolute maximum be? It's where the highest point is, right?
Yeah.
Which is there. Got it? That's your
Yeah.
absolute maximum. Now let me
Okay.
yeah, now let me
Have to
ask
be-
you, is it the maximum turning point?
No.
Yeah. It is a maximum, but it's not a turning point. Does that make sense?
Yeah.
Yeah. As far as it being a turning point, no, it's not. Okay? So that's why B's wrong. Yeah. Okay? Oh, so that's why C's wrong, sorry. Yeah. Yeah. And then D, a local minimum is the least value of the function over the given domain, and that's not right. That word should not be local, it should be global. Does that make sense?
Yeah.